Hello, welcome to this video. It's your best online tutor, PVS the Tut. In this video, I have two questions under integration which we need to work out. And the first one is find the integral of x squared with respect to x. And the second one is integral of x to the power 3 plus 1 divided by 2 with respect to x as we move from 0 to 1 in terms of limits. So what exactly are we supposed to do? First of all, when you're asked to integrate, or what we are doing is you are reversing the process of what? Differentiation. So if you know how to differentiate, integration is the reverse of that. That means it's taking you to the original function before you differentiated that particular function. Okay. So let's work out these two here. So the first one is this one here. How do we integrate? We are saying when integrating a function of this nature, a x to the power n, what you do is that increase the power by 1, then divide by the same new power that you've that you are doing that you are integrating. So you result into something like this. It's the same situation that we are going to do on this part A. So we are going to increase the power by 1. That will be 2 plus 1. We divide by the same new power, 2 plus 1. So this will just give us x to the power 3 over 3. But remember, we need to add what we call a constant of integration. Why are we adding the constant of integration? Well, we don't know what constant we were dealing with before we differentiated that equation. Get the concept, right? So we add the c. Now, for b, is quite a little bit different, but not that much is different. But there are only two steps. Step 1 is integrate what has been given. Step 2, replace the limits. This is the lower and the upper. So to say, when you replace the upper limit, you subtract after you replace the lower limit as well. So let us first integrate this. But look, you can say this is just half. Over 2 is the same thing as half. So we can take it out. So we can take that one out. And we remain with the integral of x to the power 3 plus 1 with respect to what? To x. So if we integrate this, we end up having 0 to 1. We end up having that, which will give us x to the power 4. Now the integral of a constant like this, it is just the same constant. You multiply by the variable that you are dealing with, which is x in this case. So this will just be 1 times x is just x over, here it will be over 4, but here it will be over 1 because the power is just 1 here, which is just the same thing. Then from 0 to 1 in terms of limits. So this is what we get. If you want, we can distribute this half throughout. Okay, so now we've reached at a point where everything must work out properly. So when we look at what we have here, if you want, we can distribute the half throughout, which will give us x to the power 4 over 8 plus x over 2. The limit still remain the same, just like that. So let me get rid of this part, right? All right, so we now proceed. This means is we substitute now. Where there's x, we put 1. So this gives us 1 to the power 4 is just 1 over 8. And there, we put 1 there to give us 1 over 2. So that is our upper limit. We say minus the lower limit. If I put 0 here, I'm just going to have 0 over 8. If I put 0 there, I'm just going to have 0 over 2. And eventually, whatever I'm going to get here is just a 0, by the way. So this will be a minus 0. But I know here I can't get a 0. I'm going to find my common denominator, which is 8. 8 into 8 is 1. 2 into 8 is 4 times 1. So we end up having 5 over 8 as the answer. Now, we are not going to add any units. And I repeat, we are not going to add any units. Because some of you, you've got a tendency of adding units that are not there. in this case, they haven't told us whether we are finding area or volume or what for us to say units. They just said find or evaluate. So you can't assume that this is area or this is volume. Just leave it like this. Unless they have clearly stated in the question, also in the question, that find the area or find the volume and so forth and so forth. So basically, you got it. I know you can do this. See ya.